excited to have Seb here as our first presenter, so come on up.
That was a great introduction, thank you. So I guess first off I need to join. I'll share my screen. There we go. And we should be good to go. Is that working? I have done. Wonderful technology. I am in presenter mode and it doesn't understand that. And it worked when we tried it earlier, didn't it? I am hitting play and it plays on my screen, which is not helping. It thinks we're the other way around. So, I am going to do something else. No. Yeah, so I just need to work with the screen a second. Sorry, folks. Yay, there we go. So, hello. Those of you who thought that I was going to talk about 10 things you ought to know about BDD, Cucumber and SpecFlow, when I read what the title of this entire session was, I decided that I was going to do the same material but in a different shape. So I'm no longer going to do a countdown from 1 to 10. That session, if you are still interested in it, is available online elsewhere. We can post the links to it later. This is a more up-to-date session that covers the big ideas behind BDD. And those incorporate those 10 concepts that I was talking about in the previous session. It was really designed for a 90-minute slot, so I've decided to cut it down. I believe we've got about 40 minutes. I want to leave a lot of time for questions. I'm told that there might even be people out there in the wide internet world, and in which case it would be good to get some questions in from them. So, also I stole SmartBear's title. This session has been called a number of things over the past year. It started off being called Introduction to BDD, and in its last incarnation it was called How We Can Reduce the Stress of Releasing Software. That's a bit of a mouthful. It's now around the big ideas of BDD. So, without further ado, I introduce you to the project cartoon. Now, the people in this room, I can't really speak to the people out on the internet, but the people in the room, how many people have seen this slide before? Quite a few. Certainly the people in my class, because I showed it to you this morning. So this is a slide that's been around for a long time. And really what it does, and I guess it's difficult to see from people in the room, but it talks about how we miscommunicate, or we try and communicate between the product sponsors all the way through to the end customer, and we get confused. That communication hasn't been working well, and it's not been working well for a very, very long time. So this cartoon itself dates from over a decade ago, but the problems that it's trying to describe date to much, much longer ago. So some of you will remember or still be working with processes that are colloquially and collectively known as waterfall. And the issues with waterfall is that you start off with a whole period of requirements analysis and elicitation. That then gets compiled into a large document, which then gets signed off, then passed over a fence to another group of people who might do some architecture analysis, and they do an architecture which gets signed off and passed over a fence, and so on. It goes on a bit like a game of telephone. And by the time it gets to the end, no one's quite sure if what you're delivering is what was actually asked for, and if it is what was asked for, no one's really sure if it's what people actually wanted. And that process frequently takes not just months but years, And we found that we were getting ourselves into a bit of a pickle, a lot of a muddle. Over the years, the light methodologies came in, XP, Crystal, DSDM, Scrum and the like, and they got to be called agile methods after a meeting at a ski resort, which is obviously where all the best software development methods get created in ski resorts. And the hope was that after we started adopting these lightweight methodologies, after we all transitioned to agile, this problem might go away. It didn't, right? This problem is still alive and well. It's alive and well even in high-performing agile organizations, because agile doesn't actually say anything about communication, especially Scrum, which is the most commonly adopted agile methodology. It talks about who should be in the team. It talks about what meetings you might want to go to. It talks about backlogs and burn downs. It talks about a lot of things. Doesn't say anything about how you should communicate between members of the team. It doesn't say anything about what professional activities those team members should undertake. So it's process, but without any techniques behind it. And those techniques are actually, it turns out, the really important things when it comes to delivering good software. So we need to have software where everybody understands what it's trying to do. We have to have software that is of a high quality so we can keep maintaining the flow of valuable features to our customers. We need to have good quality software so that we don't get defects from the field. All sorts of things lead us to needing to have good quality software well understood among the various professionals that are involved in delivering it. And yet, the Agile Manifesto says very little about that. Hence, we're still in this problem space. So, the first problem, of course, with any software development is that the business needs are not understood well by the people who actually want the software. So any of you that have ever had to deal with customers know that they can often tell you what they want on the screen, but they're not sure why they want it there. They might not really understand their processes. They may have a desire for some sort of functionality and an idea of what the solution is. So back in the old days, we used to say that people should come to us with requirements, not solutions. And that's still the issue. But actually, when they come to us with their requirements, they often articulate it in one way. So we're saying in the previous cartoon said that actually what they needed was this rope swing with a tire. But they come and say, well, we want it on multi-level so we can fit lots of people on it. And finally, they come up with plenty of solutions that don't quite meet their needs. The second problem is that we as software developers or teams that are going to deliver software don't well understand the needs of the business. So we're experts in the technology space. We're not so expert in the business space. So they ask us for something and we go, well, if they're the customer, they must know what they want. So we'll deliver that. And when they get it, they didn't like it, or it wasn't exactly what they wanted. So people in the room are nodding, so I'm guessing you've all experienced this in one way, shape, or form. I've certainly sat in rooms where people have been, someone's come down from the top floor, and they've said, you've got to stop everything that you're doing and do this because we need this report and we need this report now. And what we do is we actually stop, we say, wait a second, okay, you need a report, but could you tell us a little bit more about what you want that report to do? And when you find out what they want the report to do, actually it turns out there's a very simple query that you can run on the database. And 5 minutes later, they're happy because they've got the results of the query, and you're happy because you can get back to delivering the functionality that they had prioritized earlier. So they don't know what they're asking for. We don't understand what their needs are. The communication problem is pervasive, and it continues throughout the industry. Sometimes when we don't know what they're asking for, we end up delivering things that just aren't going to work. That looks like an interesting solution, but you wouldn't want your kids playing on it. There's also a problem if we don't really understand why they want it. We might do something that isn't unsafe, but it just doesn't quite deliver what they want. It might be low quality, it could be defects. It's just not ticking the boxes. They are not happy. This really, we can group that sort of behavior, that sort of functionality into a bucket and just call it defects or bugs. What we're doing is we're delivering software that doesn't delight our customers. Now, I don't particularly like the word delight. But nonetheless, what we're trying to do in any relationship, whether with a customer, is satisfy their needs, deliver to them the things that they want. The software that doesn't quite meet it, that's a defect. We can call it a bug if we want to, but it's a defect. It doesn't deliver what they want. It doesn't deliver it in the way they were hoping it was going to. And somehow we fell short. We failed them. There's another problem that stems from the shying away of Agile from talking about actual technical practices. And it's to do with the cost of change. So what you frequently see, and I don't know, a lot of you, I guess, and from time to time, look at job sites. And on job sites, there's one class of job which proudly proclaims that you're going to be working on a greenfield site, right? And this is supposed to be very attractive. So now we have to stop and think, why is it attractive to work on a greenfield site? And I would answer that it's attractive because you don't have to deal with somebody else's code, right? All the problems that there are going to be in this greenfield site are going to be of your own making. What we soon find, though, is when we get onto our greenfield site, we start delivering software at high velocity. We just keep churning it all out, but we don't pay attention to quality practices, maybe TDD, maybe unit testing, maybe peer review. The quality of the code that we deliver does not stay high. And what happens is that very quickly, our ability to deliver new features on that code base becomes much, much reduced. So the delivery pace becomes slower, and the cost of delivering each change becomes more expensive. And this curve is a curve that people and projects have followed for decades. I've already told the story to the folk on the class today, but essentially what we're looking at here is a curve that leads to a point eventually where the only thing you can do is rewrite the software. Adding any new feature is so expensive that nobody ever will give you the budget to do it. And it gets to that point where you go, right, we need to do a rewrite. And I asked the group today whether anyone had been on a rewrite project. There are 26 people in the room. I would say roughly half of them put their hand up. Anyone who's been on a rewrite project knows that it's expensive. It's hideously difficult because the only requirement you ever get is it must work like the old system, only better. Unfortunately, nobody actually knows what the old system did. And they certainly don't want you to make it work like the old system's defects. So actually, they want you to fix things along the way. So everything about a rewrite project is setting you up for a failure. So the last thing we want to do is bring a new greenfield site into a rewrite space. We don't want quality to degrade. We need to keep quality high. And actually, that's where BDD comes in. So BDD is part of the solution of improving communication between the business community who know and understand what their customers are doing and the technology or delivery community who have the job of delivering that high quality software. So let's think about what a successful project looks like. So there's a few things that I think we look for in successful projects. So the first one is that everyone on the team has to have the similar, if not identical, understanding of what the project's about. If one person thinks it's about delivering a roller coaster and the other person thinks it's delivering a tire on a swing, we're going to end up with people being disappointed. Shared understanding means that we have to communicate effectively. Not for those at home, but for those in the room. Hands up if you think you communicate effectively. Yeah. Has anyone ever misunderstood you? Yeah. So we can, even though we know that we communicate effectively, we know that we can get better. Shared understanding requires us to make sure that that understanding is unambiguous across the whole of the community, from business through to delivery. We also need to know when we're finished. So one of the problems of projects is scope creep. We keep on delivering stuff, hoping that the customer's going to sign off on it. We're looking for someone to define the scope in a way that we can essentially see a little checkbox go from red to green when we have delivered on what we've agreed to. At that point, we're in a good place. We can put the software out, get some feedback on it. Without knowing when we're done, we're in a continuous cycle of trying to catch up with the latest crazy ideas that our customers are coming up with. There's also a problem of knowing what you want to do next. So we have, certainly within Scrum, you have a sprint, per sprint prioritization, where you pull things off of the product backlog onto the sprint backlog, and now you know what you're going to do next. Actually, though, when the development team comes in, they look at the Scrum board, and it's like, well, which thing should I pull off the sprint backlog? Should I be doing some testing today to assist with getting getting products across into the done column? Should I be pulling something new off? Should I be doing some work on something that's already in progress? One of the things that can really help with the development team's ability to know what they should be working on is having an acceptance test that's failing, that says, this is something that needs to be passing before we can consider this piece of functionality in the product done. And this failing test can be a really good driver. Those of you that have worked in a TDD approach know that the next failing test that you write is something that gives you absolute clarity about what code you need to write next. That test needs you to write a specific piece of code and only a specific piece of code to move on to the next increment of the product. The failing acceptance test is something that at a coarser level of granularity tells you which piece of functionality you're working on now. And when it's failing, you know you have to get it to pass. When it's passing, you know you can go back to your Scrum board and pick on the next thing to work on. This particular requirement of a good project is what I was talking about earlier when we were talking about the cost of change. We're looking for a code base that remains clean and malleable, something that doesn't have areas which have cryptic comments from developers which say, here be dragons, right? So there are many code bases have areas where nobody wants to touch them. What we see around those is that people will do pretty much anything to stay away from that area of the code base. They're going to copy and paste huge chunks of code and then put a branch in early on in the process just to be able to avoid touching the dangerous code. And the problem with this sort of behavior means that the ability of the team to quickly and cheaply deliver quality code in response to customers having changing or new requirements is severely limited. And at that point, our agile is no longer agile. Some people might call it fragile. It's a place where pretty much every time we touch the code, it takes longer than we expect it will. Something breaks somewhere where we didn't expect it to, and what we have in the end is an increase in the cost of doing any development and a decrease in trust between us, our customers, our business, and our QA. We need to avoid this at all costs. And then the final part is that when we are changing the code, we really want to know as soon as we've done something bad, right? As soon as we have crossed that line and changed functionality and broken something that was already there, we need that feedback so that we can fix it. Now, the typical way a lot of teams that I work with do this is they go, test will tell us, right? So many teams have got a manual test process. Sometimes it's called a manual test tail that comes at the end of a development cycle. It might be a 1-week cycle. It might be a 3-week cycle. The tail, I've even seen 3-month tails. That feedback period is way long. You don't know immediately that you've broken something. You know eventually. By the time you find out, half the team might have been rotated onto a completely different project. Nobody can remember exactly what they were doing. So it's very important if we are inevitably going to break things as we go. But when we break things, it's important that we find out about it really quickly. Because if we let time go on, people will have built more stuff on top of that broken code. We'll have forgotten what we were doing and why we did it in that way in the first place. And probably we may even have lost the track of what the requirements were that caused us to write that code in the first place. So successful products and successful projects to some extent as well exhibit these properties. We have shared understanding across the team. We know when we've finished a particular piece of work. We always know what we need to do next. The code itself supports change. It's easy to change. There's no areas that we're really frightened of. And when we do inevitably break something, we find out really quickly so we can fix it. Now, all of these things most of you, I'm sure, are thinking, yeah, we do all of this. But let's dig in a little bit deeper. So, BDD, and this is, I guess, why I'm calling this the big ideas behind BDD. I think BDD is made up of 3 constituent practices. It's made up first and foremost of discovery. So discovery is a practice whereby we as the team, and the team here being the developers, the testers, and the product owner or business analyst, so someone facing the product, someone facing the customer, someone facing the development technology, and someone facing the test perspective, collaborate together to try and dig into detailed problems before we start working on the code. This is called discovery because it's built on the idea that there's always stuff we don't know. You should never go into a project thinking that you know everything about it. As we talked about actually this morning again, there's never been a project or team that I've worked on that when they finally released their software, they got together and said to themselves, do you know, if we were to do this work again, we would do it exactly the same way. Right? That never happens. And that never happens because the journey of developing software is always a journey of discovery. It's always a journey of learning. The trouble is that quite often, that journey of discovery, the discovery happens accidentally. It happens while you're actually working on the code. And that can derail your plans. It can derail your expectations because you weren't expecting it to happen. You already made estimates. You've already made commitments. And now you've found something out that pushes you off in a different direction. Joe?
Balance between discovery and what some would consider to be taboo, which is scope creep.
So the question was, how do you balance between discovery and scope creep? And there's no solid answer, but basically one of the people that is involved in discovery is the product owner. The product owner faces off to the business. They are your portal to what the business requirements are. If the product owner decides to go in a different direction, you go in a different direction. It might be creeping along, but actually all you're doing is you're saying, well, our previous estimates are wrong because we've discovered something new. What I would submit, though, is it's best to find that out before you've done all the wrong requirements, and then you have to backtrack and do the rework. So the discovery process, as described here, is creating a shared understanding. What we found in the Cucumber organization is that the best technique for creating that shared understanding is to have the developers and testers think up concrete, detailed examples of how the system should behave. So given a particular business rule or acceptance criteria, you actually actively sit down and think about, now what does that mean? In this situation, how should the system behave according to this rule? In a different situation, how should the system behave? And they work through, core examples of the system behavior, happy path examples, negative examples, boundary conditions, exceptions. And what we found time and time again is that developers and testers come up with examples that create a level of realization between them and the product owner that was not there before. Frequently, ambiguities are surfaced. Frequently, assumptions that the business had made are surfaced. Frequently, developers ask questions that lead product owners and business analysts to question whether they've made the right decision. And together, we reach a point where we have a better understanding of not only what we're being asked to do, but how we ought to go about delivering it. You may have heard of this, something called shift left. And in fact, I'm pretty sure that your slides, the slides of the presenter after me, are going to talk about shift left. Shift left is often defined as doing testing earlier. I would suggest that what we're talking about here is doing testing earlier. But what we're testing is not testing the code. We're testing our understanding of the requirements, the fitness of the requirements, our ability to actually deliver on those requirements. Because every question that comes up during this discovery phase is a question that otherwise developers and testers would ask themselves while writing code or designing test plans. It's just that if they have a question they can't answer while writing code or designing test plans, they've got no one there sitting next to them to ask. They have a choice. Do I make an assumption? And assumptions are sometimes wrong. Or do I have to go and find someone? In which case you have to stop what you're doing and go and stop what they're doing as well. Potentially you have to wait for hours or days for an answer. So discovery is a hugely valuable practice. We believe it's the first and most valuable practice of BDD. The second practice of BDD we call formulation. So formulation takes those concrete examples that came out of the discovery phase and converts them into business-readable English language specifications. I come from the Cucumber team. The Cucumber product uses the Gherkin specification language, which has the famous given, when, then keywords. Other specification languages are available. This practice of formulating the examples in business-readable terminology allows the team to collaboratively create a shared domain language. So a domain language is a language that accurately and unambiguously describes concepts within your business domain. So we're not necessarily looking for words that are common in the rest of the world. We're looking for words that describe concepts in your business. So for instance, the word customer is typically a word in everybody's domain. But most organizations have more than one sort of customer. So if you start seeing an example that talks about customer, there's a question about, well, which sort of customer? Are we talking about all of our customers? Are we talking about business customers, retail customers, high net worth customers? And when you make the decision on how to describe it, now you're talking about the business domain. You're beginning to build what's called your ubiquitous language. Now the concept of ubiquitous language comes from a technique called domain-driven design, which was popularized by a guy called Eric Evans quite a long time ago. It's received quite a bit of traction, but this is one tiny little concept from it, which I find extremely useful, because ambiguity is the thing that slaughters many projects in their tracks. So we get the examples to make sure we understand the rules. Then we have the examples, we write them out in business language, developing our shared ubiquitous language as we go. The wonderful thing about that is we can now show it to our product owner. We can show it to our business stakeholder. Potentially we can even show it to our customers and say, is this what you wanted? Because it's written in their language. It's written in the domain language, the language of the business. So now we've got people that can share in the specification, can give us feedback. It's specification that's shared between developers, testers, and business people. This is something that we have never achieved before. The final part of the BDD process or practice is the third practice, which is automation. This is the practice that gets the most fanfare, right? So I don't know whether it's true, but this is generally what brings people to tools like Cucumber. It's like, oh wow, we can do automation of English language specifications. And it is really cool, but it's the third and not the most important of the practices. The trouble with getting hung up on automation is that you do exactly that. You're getting hung up on automation. Whereas the problems are not that we can't automate. We've always been able to automate. The problem is that we've never been able to agree on what we wanted to automate or how to describe it. We've got automated scripts all over the world. There are people here who will have used a wonderful tool known as Selenium. Now, well, when Selenium shipped with record and playback technology, people went, wow, we could automate. And there are now teams that spend their entire life keeping those record and playback scripts running. Or more likely, there are entire dumps of Selenium record and playback scripts that don't run anymore. Because we never thought about what it was we wanted to automate. We just went, what's the easiest way of making a computer do what a human used to do? This is not what we're trying to do. What we're trying to do is describe the product, describe it in a language that we can all then collectively go, yes, that accurately and unambiguously describes the product that I want you to deliver. And then, guided by that unambiguous description, automation engineers or developers can automate that English language specification. It's entirely different from record and playback. And I would suggest it's entirely different from trying to do automation first and then moving back up the stack. Which is why when I describe these three practices, I then want to add on to the side of it this arrow. I believe that if you want to practice BDD, you should, and you owe it to your team, start with discovery. move through discovery to formulation, and only when you've developed a shared ubiquitous language, then follow on with automation. I know a lot of people haven't worked in that way, but what I can tell you is for the past 5 years, I've been going out and consulting with clients who have been working with Cucumber, and we've been picking up the pieces of a back-to-front adoption of Cucumber-style automation. It's not a pretty sight. So I've got 3 slides now that cover each of those 3 practices in slightly more detail. There's lots of ways you can do discovery. Discovery really is about collaborating to try and make sure that we all have a shared understanding, that we take as many unknown unknowns and turn them into known unknowns as possible. The technique that my colleague Matt Wynne has discovered is called example mapping. It happened in a magic way. He bought a stack of index cards, and it was a pack that had 4 colors in it. And he was trying to work with a client, and they weren't quite getting this idea of coming up with stories that have scope governed by acceptance criteria and examples that illustrate the acceptance criteria. And he thought, you know what, let's just draw it out. So he drew it out. And it happened that there were 4 colors in the pack, and he started using the pink cards for questions that were outstanding. And it just clicked with that team. And he tried it on a few other teams, and it just worked. So this wasn't something where the theory came first. This was fortuitous. We understood the concepts that we've got stories, that stories have a scope that are governed by their acceptance criteria, that acceptance criteria need to be checked, need to be tested, need to be understood, and that examples, that's what tests are. So he drew it out. It was magic. You can go and buy 4 packs of colored cards down at Staples for $1.49, way cheaper than any software. And the great thing about cards is anyone can write on them. The great thing about cards is if you're sitting in a room, you can play with them, you can move them around. The great thing about colored cards is that they give you immediate visual feedback about the state of your understanding of this particular story. So if you get 20 blue cards underneath your story, it's got a lot of rules. It's got a big scope. Guess what? It's probably too big a story. If you've got a lot of pink cards, well, there's probably a lot of outstanding questions. You don't really understand this story well enough to work on it yet. If you've got rules that have got no examples on them, well, how are you going to test that? You haven't thought about it yet. So you get really wonderful visual feedback from this. You also get another benefit. If you end up with 20 blue cards, it gives you a wonderful way of splitting this story into multiple smaller stories. You just group the rules into different buckets and you say, that's a story, this is a story. So you almost get story splitting for free out of this process. I could go on. I'm not going to. So on this slide deck, there's a link through to the original blog post by Matt Wynne about example mapping. It runs to 5 or 6 pages. And then underneath it is a YouTube link to the Cucumber team doing a demo of example mapping live online. Both of those are worth going into if you want a bit more detail on example mapping. Once we've gone through the discovery, now we're thinking about formulation. So formulation can be done in many different ways. As I said earlier, I'm from the Cucumber team. I'm going to talk about gherkin. So on the left here, we have a very simple feature file. You see most of the syntax of gherkin in this feature file. It starts off with the feature tag, the feature keyword, and a name that describes what feature is in this feature file. This feature file, by the way, is just a plain text file. You can write it in Notepad. The words that come after the feature title are the rules. So you remember the blue cards from the previous slide? The words that you would have written onto those blue cards get transposed into the feature file. So this feature file is about team scoring, and the rules that the examples in it are illustrating are that teams start with a 0 score, and that a correct answer gets points depending on how difficult the question is. So that's all that describes. And then underneath it are these keywords that say scenario, and each of these scenarios is one of the examples that was discovered in the discovery, in the example mapping session, translated, formulated into your business domain language. So the example card that came out of the example mapping session becomes a scenario. At that point, you can throw away the example card. This feature file is going to get committed into your source control system. It's going to be versioned. You're never going to lose it. The rule card, as I said, gets translated into the preamble of the feature file. So at that point, you can get rid of the rule card because it's been written into the feature file, committed into source control, and versioned forever. And then finally, the story. So I don't know, maybe it's because I'm from the UK, but I like trying to wind people up whenever I do a session. So a story has become one of the most important artifacts in agile processes. If anyone has ever surfed the web, you will find people arguing about what makes a good story and what doesn't make a good story. There are books by very famous agile coaches about how to write good stories. There are acronyms such as INVEST about what a good story should look like. You have tools called Jira and the like that have promoted stories to a very high level of importance within the agile process. How many times does the Agile Manifesto mention stories? None. Zilch. Ditto. None. So what I think you should do with a story, once you've taken the acceptance criteria and the examples and transposed them and formulated them into your feature file, is I think you should throw it away. Now, I know that Jira doesn't let you do that. Nonetheless, the thing that I find most annoying about stories is that if you keep hold of them, people begin to think that they are a record of what the system does. Whereas we all have experienced the fact that stories are merely increments that help us evolve to where the product is now. So if you look at a story from a year ago, chances are it's just not true anymore. So it would be better if we could throw it away. Anyhow, there you go. That was my angry man in Kent speaking about user stories. Finally, let's talk about automation. As I said, automation is the bit that brings people to Cucumber. It brings people to BDD. So I shouldn't be I'm not bad-mouthing it. Automation is really important. It's just, please don't do it first. Automation from a Cucumber point of view is driven by the specification. The feature files that we just looked at are what drive the automation of that level of acceptance tests. Feature files contain scenarios. So the scenarios are what we saw. They are formulations of examples that we discovered during discovery. The scenarios are made up of steps. So I didn't actually introduce them on the previous slide, but if you remember, it said given, when, then. Each of those is a step. So those are keywords, and the keyword introduces a step. So each scenario is made up of one or more steps. The steps are written, and the whole feature file conforms to the Gherkin syntax. Yeah, each scenario is an example. On its own, that doesn't do anything. We need to somehow glue our specification to the application that we're trying to develop. And this is where the automation code comes in. Cucumber typically calls this glue code because it glues our specification to our application. But it's just plain code. You create multiple step definitions. So step definitions are very simply just methods. So in Java, they're Java methods. In JavaScript, they're functions. In Ruby, they're functions. So you see the pattern. It's just code. It's plain code. The step definitions are written in a multitude of languages. So I advertise this for being for Cucumber and or SpecFlow. So SpecFlow is the .NET port of Cucumber. So if you're going to use SpecFlow, you'll use one of the .NET languages, probably C#, for writing your step definitions. If you're using Cucumber, there are in fact 3 flavors of Cucumber operated by, actually it's 4, operated by the open source project, and that's Ruby, Java, JavaScript, and C++. If you work in another language, Python, PHP, pretty much you name it, anything, there is a flavor of Cucumber or a port of Cucumber. So there are some called Behat, Behave, all sorts of them. So if you want to use Gherkin on your favorite development platform, there's a very good chance that a library exists to allow you to do that. Cucumber only cares about your feature files and your glue code. This is such an important thing that I'm going to say it again. Cucumber only cares about your feature files and your glue code. It doesn't care whether your application is a web application. It doesn't care whether it's a web service. It doesn't care whether it's a desktop application. It's your job to write automation code that interfaces with your application. You can use any library that's available on your platform. If you're working in Java, there's a good chance that there's a library available that will interact with pretty much any system that's ever been developed. But Cucumber doesn't care about that. It's your job to find those libraries. So specifically I need to address web applications. When Cucumber was first released on Ruby, we also released something called web steps, which was a set of steps that were intended to make it easier for people to automate interactions with web applications. We quite quickly realized this was a really bad idea, and we have deprecated and removed web steps from the open source product because we don't want to encourage you to always go in through the UI. We don't want to encourage people to go straight to automation, thinking about pages and page objects and buttons and links. Cucumber doesn't know about Selenium. It doesn't know about web applications. It just knows that it will call some automation code, a step definition, in response to every step that you write. So what happens is that Cucumber comes in, it reads your feature file, it finds the first scenario it's going to run, it picks out the first step, it looks for step definition to run in response to that step, it calls that step definition, and then it's over to you. And you do the automation in whichever way makes sense. And that will then call your application. And like I said, it could be just a direct method call from a Java method to a Java class. It might be a web service endpoint. It might set up mocks. It could do anything that you like. So importantly, one of the things to pull out from that means that Cucumber automation does not need to be end-to-end. It can be an integration test. It could be a component test. It could be a unit test. The feature file doesn't limit you. The feature file asks you to describe a behavior that illustrates a rule in business language. And the choice of how to automate it, where in the automation pyramid to place it, is up to you. And we would suggest that you stick to the automation pyramid and keep those tests as far down as possible. Finally, a slightly, what would you call it? A process diagram. So some people like process diagrams. They certainly help pull it together. This process diagram comes from the book that myself and Gaspar Nodge released earlier this year. It's called Discovery. You may already be able to guess why it's called Discovery. It focuses on that aspect of behavior-driven development. And what we're saying in this diagram is that actually BDD fits really nicely into a standard Scrum-style XP process. So down here in the implement phase, we've got red, green, refactor. This is TDD. Up here, we've got picking a user story. This is the product owner prioritizing the backlog. Down here, we've got things that are slightly new. So we've got a requirement workshop, which roughly maps through to maybe refinement or grooming, depending on what language you want to talk about. It's an example mapping session, basically. We suggest you run these regularly, keep them short, because we love short meetings, right? We hate long meetings. So we want lots of short meetings where we can build out these example maps, ask questions about things that we don't understand, make sure that we really understand the requirements. Then we have concrete examples that come out, which we formulate. We convert them into scenarios. There's a lot of discussion about who should do that conversion. I'm not going to say who should do it, but I'm going to say it's not the tester's job. It's not the business analyst's job. It's a job of the team to make sure that those formulated scenarios make sense, are grounded in the domain language, can be understood by everybody. And this process of formulate and review means that not everybody needs to be part of the formulation, but everybody needs to be included in approving the signed off specifications, because we all are going to build and rely on this documentation for as long as this product lives. And then we automate it. Here, this is actually part of the development process. In the same way that TDD can be thought as test-driven design as well as test-driven development. BDD is behavior-driven design and behavior-driven development. Writing that automation code will help you think about how your user is going to interact with the screen, perhaps, how your user is going to call your API, how your user is going to structure the JSON package that is going to be passed to your web endpoint. So this is not a job to be done on the side by someone who's not involved with the product. This is part of the team's responsibility, because this automation will drive the development and implementation of the product, and it will influence the design of the product. And then we have supplementary tests kicking out the back there, and finally, hopefully, we release something. So this is a process that you should not take as gospel. This is an idealized diagram. This is a diagram that may not work for your team or in your context. So like with anything that works in the Agile space, you obviously have a retrospective every iteration. At every retrospective, people reflect on how the last iteration went and make suggestions about how they might want to change it. And I hope you come up with a process that fits your way of working. And if you do, please share it with the rest of the community. Finally, you've got to have a bit of a plug, don't you? So there's a couple of books. The Cucumber for Java book is very similar to the Cucumber book. They're both from pragmatic programmers. They cover the full gamut of discovery, formulation, and automation. Clearly, the Cucumber for Java book is for people that are going to use Cucumber for Java. The Discovery book is a much smaller book. It's only 100 pages. I worked with Gaspar on writing this. Gaspar, by the way, is the guy who created SpecFlow. So this is a joint project between SpecFlow and Cucumber. And it goes into a lot of detail around the discovery process and the example mapping process. You can get it from bddbooks.com. And I think that's all I've got. I've overrun. Do you want to ask for any questions? Okay. So does anyone have any questions?
So with people who are learning Jerkin and those who have difficulty with the real structure of that, what techniques do you use to help people kind of work with that structure?
Okay, so that's a good question, because there's no really good answer to that. I guess one of the techniques we use is that we publish some Gherkin. We've got some advice about how to write good Gherkin. It's not widely available, it's true to say. So I shared some of it with the class that I ran today. I'm more than happy to share that more widely. So maybe I should take this as an action. I will take those 2 pages, which has 6 properties of good examples and good scenarios, and around 15 tips for how to write good examples, and I'll publish those as a blog post on cucumber.io in the next week or so. I guess given that I was doing a plug, maybe I should do another plug, which is we're also working on a book called Formulation, which is a sequel to the book called Discovery, which will go into it in probably 150 pages of detail. But that won't be out for quite a long time.
I was wondering if you happen to have these slides on slideshare.net or some SlideShare program.
Yes. They're already on slideshare.net/Sebros. They're under a different title. I think they're under Intro to BDD at the moment. Okay, so first off, I'm going to refer you to my previous statement. Cucumber doesn't pay any attention to that. So there are a number of different ways of doing it in the automation layer, and that's entirely under your control. So if, for instance, you're working against, you're going to use WebDriver, then you can run the scenarios multiple times, invoking different Selenium WebDriver instances each time. I believe BrowserStack has some plugins that allow you to use Cucumber up in that space as well. I know that there's some in the .NET space, but I guess I'm slopey shouldering here. This is not the job of Cucumber. Cucumber's job is to take the documentation, allow you to formulate it and get feedback on it, and then connect it to automation code. And the way you do the automation, I'm afraid, is undefined by Cucumber.
Seb, I had a question about BDD and product owners. I found my experiences that development and test teams are more happy to adopt more of a BDD approach. But if you use the term BDD I found if you use the term BDD too much, people think it's something brand new and have some fear of it, and the product owners are the hardest ones to actually pull into BDD. So do you have any suggestions as to how to get them, I guess, sucked into drink the Kool-Aid?
Okay, how to slip it under the product owner's guard. So the first thing is I've worked with the team recently, and they observed exactly what you're talking about, and there are 3 different names for BDD. So BDD is one of them. Another one is often called acceptance test driven development, or ATDD. But the third one, which is the one you should use if you want to sell it to product owners who are not so happy, is specification by example. So just put the specification by example label on it, and it's not new at all. It's like specifications. Yeah, we do that all the time. Now the actual problem, the first problem is getting the name across. I think that is a significant issue, and actually I prefer the specification by example as a description of what we're trying to do. The second problem, though, is actually getting people to talk to each other in an active and engaged way. So even once you've convinced them that specification by example isn't as frightening or as development focused as BDD, you actually need to facilitate, bring them into a space where they have time and support to actually build up that trust, begin to understand that we can talk to each other, that developers, aren't all role-playing games monsters, and that product owners aren't all pointy head bosses, and get them in a space where they can actually work together and build that trust. Actually, I've never met a team yet that has spent one sprint working together in a discovery workshops with example mapping that hasn't come out of it a closer, more tightly knit team. I've actually met plenty where they decide not to go down the automation or formulation route, but they're still getting vast amounts of value just out of discovery. And for me, that's the place to start. Get people talking to each other, call it whatever you like to get them to talk to each other. Start bringing examples in slowly, see whether that helps with the conversation, and from there, just see where it goes.
And, Rob M. online has a question for you. For small development shops, how does one justify the cost of adoption of BDD?
So all adoption of BDD should be predicated on saving money over the lifetime of the product. So I don't believe you need to justify it, you need to demonstrate it. So I would say that even in small development shops, features become harder progressively to deliver because the quality of the code often deteriorates. Even in small development shops, you bring on new team members and you need to get them up to speed because the documentation is either inaccurate or missing. Even in small development shops, people change their mind and want different requirements. The customers, you see a new opportunity. So actually, it's really a question within a small development shop of can you afford not to be really agile? Because you don't have 10 extra teams twiddling their thumbs down the road that you can throw in a problem when suddenly a customer says, we've got to have this by Friday, or otherwise we're going to go with a competitor. So yeah, I think it's not that you justify the cost, it's can you justify not doing it?
When you were talking about discovery, I was thinking about a book I recently read called The Lean Startup, and the idea of minimizing as best you can that build, measure, learn feedback loop. How do you, or have you thought about how BDB meshes in that type of mindset? I mean, do you recommend, for example, that the automation occur once you've gone through several of these feedback loops, and that sort of is your discovery phase and maybe even your formulation phase, and then when you get something that you're kind of honing in on through those experiments, you're honing in on an MVP, is that when you really want to focus on the automation?
So Joe, thanks. That's an interesting question. It's not one that I've done too much thinking about, but there's an interesting space here because the same question has been asked about TDD for as long as I can remember. And the same answer as I gave to the last question really apply. So the problem that I find with any taking of shortcuts during an experimentation phase is that, well, although we always say we're going to build one to throw away, if the one that we built is good, we don't throw it away. And if it was good enough to not throw away, then they're going to want more features, and they want more features tomorrow. And so, again, the question is weighing up the cost versus the risk. So, yeah, we'd like to move fast, but actually, typically, TDD helps people go fast. And, yeah, BDD is an extra cost on top of that. But if you're doing an MVP, there are probably minimal rules that you're going to be implementing. There are minimal rules, then there are not going to be many examples. There are not many examples, there are not going to be that many scenarios. Automating that now begins to allow you to think about what's the design of this structure. Let's do something really simple. Now, at this point, we've described the behavior in our feature file. The behavior we then automate through to our MVP. And if later we go, wow, that's really good, we're going to try and make $1 million out of this, maybe that architecture is rubbish. We throw it away. The feature files are still correct because they're still talking about the business value. So you've already done your specification. What you need to do is just re-implement the automation. So actually, it's a cost, but it's a cost that gives you a really good place to grow from.
Okay. Let's see. Lika said, can BDD be done without automation? And additionally, is Cucumber the only way for BDD?
Yes, BDD can be done without automation. So discovery is one of the core practices of BDD. You never have to go as far as automation. Formulation can be done without going into automation, although I see that much more rarely. Automation and formulation can be done using other tools. So there is Cucumber and SpecFlow. Precursor to Cucumber is a tool called JBehave. That also works in this space. A precursor to both was Fit and Fitness, which Fit is a command line based tool, and Fitness is a wiki-based product that Bob Martin built on top of Fit. So yeah, there are loads of other ways of doing it. And in fact, if you have a look at, this doesn't actually directly address that question, but if you have a look at Nat Price and Steve Freeman's book, Growing Object-Oriented Software Guided by Tests, they do pretty much BDD using just JUnit. And so they do the external acceptance test being driven by tests written in JUnit with intention-revealing method names, and then they go into a much more low-level TDD cycle within that.
Great, thank you. And Laxmi Patri asks, is this tool going to be an integrated tool? Meaning, can web services and web UI and backend database and mainframe tested on a single test?
So I'm afraid I'm going to just direct you back to my previous statement, which is that the automation code is entirely under your control. So a simple answer to you is yes, because if you've got a product that starts at a UI and goes all the way through to a backend and a COBOL mainframe job, well, then you just write an end-to-end test and wait for the result to pop out somewhere. But Cucumber doesn't stop you from doing that, but neither does it give you any special magic powers. You have to use libraries that already exist. TJ.
Thank you. What is the pro version of Cucumber? I was seeing that on your website.
I didn't even pay him to do that. So, so Cucumber Pro is currently in private beta. Cucumber Pro is a tool that sits on top of people working in the Gherkin, using Gherkin to formulate, and it provides a web front end of all of your feature files structured as hyperlinked documentation. So it basically publishes your documentation in a really easy to read way. It also allows you to comment and have conversations about that the ubiquitous language. So it's a great place to collaborate on suggesting changes or saying we don't like this terminology or can you modify this. It also collects the results of Cucumber test runs. So it's a single place to see your specification, discuss the evolution of your specification, capture the results of whether the product currently meets the specification, and finally, I guess, lastly, but by no means least, it's a place where we can version the specification. So a lot of large corporations, they want to know what version of the spec is currently in production, what version is in a particular stage of the build pipeline, and so it also allows you to do that.
Great, and we have a question, probably one of the final questions before we move on to the next presentation of the night is from Mainder Singh. Excuse me if I'm not pronouncing your name correctly, but he asked, is this compatible with Ready API for the API tests?
I'm afraid back to the same response. It's not compatible with anything. It's automation code, and if you've got a library that can work with your Ready API that's written in Java or any other supported language, yes, you can use it. Thank you very much. Thank you.
Seb, if you could stop sharing. And Prashant, if you can head to the front to get ready for your next presentation. Here's your clicker. You have this here.
Awesome. Thank you.
Good.
Perfect. Perfect.
All right, good evening, everyone. My name is Prashant. I'm one of the product managers here at SmartBear, working on a couple of UI automation testing tools. And this is Ian, working with also the test team as a sales engineer. And he'll walk us through a small demo of what we think, some of the ways that we can embrace the shift left movement that we're going to talk about. So I know Seb touched on this, but I was just wondering if anyone here actually sort of practices or really embraces shift left in their companies. I guess not. So this is good. So it's perfect. Oh, we have one. Fidelity, yes. All right, so we can get started as soon as this starts working. Can we just use the computer? Sorry, guys, we didn't test this well enough, I guess. Awesome. So just going back to the basics here, right? Some of the some of the different phases in the software development lifecycle. So we've seen many variations of this, but here's a simple one, right? So we start with the design phase, we have the development, and then we have the testing phase, and finally operations or maintenance or many things that we call it. And we don't really think about quality until we get to the test stage, right? And should turn green, but yeah. So so we don't think about it, and often it's too late. And you know we've already lost a lot of money. And I just want to show you a little statistic here that IBM sort of ran this a few years ago. This test. So cost to fix a defect, right? I know Seb touched on this a little bit. So if it costs X dollars to fix a defect in the development stage, costs about 2.5 times more in the test phase, and once you go into production and the operations and the maintenance phase, it's 15x, right? And when we try to put a simple dollar figure to it, right? So we're talking about maybe 2 hours on average to fix a bug, and $50 an hour for a developer, just being very conservative here. We're talking about $100 to fix a bug in the development phase, and then as you go right to the end, you're talking about $1,500 for one defect. And most applications don't have just one defect, and so when you multiply that 10 times, 100 times, the cost just becomes really high. So what do we do, right? So basically just, forget about testing, right? We've seen this also, we're hearing about operations and the development phase coming together that we normally term as DevOps. And so what this essentially means is taking the test phase and spreading it across these different phases here, right? And so testing can mean many things here. So we're thinking about, obviously, quality, thinking about developers getting involved in the testing phase early on. Seb touched on this several times, and also even beyond that, and that's where things like BDD and TDD come. When you're actually in the design phase, when you're designing the application, that's when you really have to think about quality. And so essentially, you just spread testing across the different phases, and essentially that's just the way it's better quality in delivering the product. So a simple definition here. So I'm just going to read this out. What we think shift left really means, right? So it's an approach to software development where quality is considered and testing is performed earlier in the life cycle. So comes in various flavors, right? And we'll go through them really quickly, one by one. So one of the ways that this can happen is that testers involved early in the phase. The second way this can happen is that business analysts, product owners, write requirements in the form of tests. This is another flavor. And finally, I think this is what we want to sort of emphasize in this session here, is that developers are also writing tests. So why is it important to shift left, right? So what are we achieving out of this? Testing early, testing often. So what does this mean? So we have this iron triangle that we keep talking about, and a couple of things here, right? So the first thing is speed. So we have shorter cycles. We get more feedback quickly, and so that means essentially we're just able to test more and test often. And then the next one, we think about the quality. We're testing often, so we're finding more defects, and that means essentially it's better quality of product. And finally, we already spoke about this. We saw that it's much cheaper to fix defects early on the cycle than not. So what's required to shift left? Right? So again, this is another little framework. We have a people, process, and tools framework. So in this specific graphic here, we've left out the tool, and Seb touched on this also. It's not the tool that's important to shift left or to think about quality early in the cycle, but it's the process and the people that are involved. And again, there's many processes, many types of people involved. In this specific case, we'll go over one set, one flavor of this. So automation is definitely important. So if we want to successfully sort of improve the quality of the product in a larger scale, it's important that automation is infused in different aspects of your process. And the second thing is developers, right? So developers are people generally, you know, focused in their silos, and we've seen that with our own teams here, and something that we're trying to you know, get them to test more and get them involved in the quality mindset as soon as possible. So we conducted this experiment over the past 2 years, you know, just talking to our prospect base, talking to our customers, just to see if something like this is something that's really happening. And you know, so here's some of the things that we got out of that experiment and some feedback. So they're saying, you know, like creating more testable code is important. So once you think about quality in the beginning, you write code so that it can be tested. Again, very closely aligned with the BDD process. Collaboration between different people, developers, QA, and the product team. I think that was one big feedback that we got. A lot of developers said that they code in sprints, right? Which is the whole agile methodology. And now they can test in the same sprint too, with them getting involved early on in the cycle. Couple more things with continuous integration, maintaining a single code base, just easier to manage, easier to maintain. And the most important thing is quality is thought about in every step of the process. But it's obviously not easy. Right? It's easier sort of said than done, sort of thing. So one of the big pushbacks that we saw, that we heard about during our experiment, was that developers already test, you know, at the unit level and at the API level for the most part. But important thing that we want to bring about is that we often forget about the UI, right? I know that that is something that's tested at the end as part of your like end-to-end flow, but it's something that the customers see on a every time they get to your app, the main thing that they see is the UI. So that's something that we shouldn't forget about. So another thing is developers don't know what to test, and I think, you know, the BDD, TDD process sort of enables them to understand, you know, from a testing perspective. Another thing is, you know, we're too far in the process to change. So again, this is something that doesn't have like a single answer to, but it's something of a habit that should be formed so that it can be easily employed. And finally, you know, this is the thing that we hear all the time also. So I don't know how to shift left, right? I don't know what to do. I don't know how to think about quality in every step. And so that's why. So we sort of, you know, we sort of took like a step back and said, okay, how do we achieve this in a simple, easy way, utilizing all the cool things that the BDD framework offers for us in terms of doing everything early and the discovery process, the formulation, everything that Seb spoke about. And we combine that with the tool that we use here. So this specific tool helps us in the automation phase. Right after Cucumber or SpecFlow gives us everything in the first two phases. And then we combine that, and we think this is one way to achieve some sort of a shift left motion. So I'm going to hand it over to Ian now, just to walk us through a quick demo, 10 or 15 minutes. Please feel free to ask any questions. We'll summarize what we learned in a slide after the demo, and we're always open for questions.
Awesome. Thanks, Prashant. So hello again, everybody. Yeah, I'm gonna put it up in a second. I just wanted to reintroduce myself. So again, my name is Ian Higginbottom, and I'm a sales engineer here at SmartBear. So we're gonna be taking a look at test left. Let me get it up on the screen here.
So in this phase, done the formulation, right? Now we've got together and already sort of come up with a scenario that we want to execute. And in this specific scenario, there is a UI that we're testing that Ian will walk us through. So go ahead, Ian.
Awesome. So this may look a little familiar from what Seb was showing us. So right here we have our feature file. So I'll just go through it really quick. So we're just describing basically what our test is going to be doing here. So at the top level, it's kind of like a meta description. I just want to make sure that I'm adding in order results in a successful UI change. So from there, we have our scenario. So our scenario is adding a new order to the orders application. And then we have our steps from there, or examples as Seb had called them. So let me just show you really quickly what application we'll actually be testing here. Can everyone see that okay? All right. So like I mentioned, we're just going to be going through this application, adding an order, and then we're going to validate that the order says the predicted information.
So real simple test. This is just a simple UI that we want to just showcase how we can convert this feature file into step definitions and UI automation code that Ian will walk us through.
Yep. Yeah. So what we can do here is we can actually generate the steps right from the feature file. So I'll go ahead and do that. Oh,
they're already bound.
Yeah,
so
sorry, it's already bound to a step definition. But what we can do is we could just jump right to that definition here. So this is what the actual glue code looks like here. So for instance, that first given statement corresponds to this step right here, where we're just launching that web application. Also, so just to talk a little bit about how we're generating this information right here, let's take a look at the TestLeft UI spy.
So this is a little pitch about the product itself. So how do we get there, right? So how did we generate those methods, those properties of each object in that web orders application? So that's what TestLeft's about, and Ian, I'll let you describe it.
Sure. Yeah. So the major value here is we could just take a look at the objects running in memory, and we can generate either a whole model, maybe like a whole page model from here, or we could just copy an identification. So maybe, for instance, in that web page, I want to interact with this page object. I could just right-click here and choose Copy Model. And if I go back into, wherever I would like, really, but I'll just add it down here at the bottom of the step definitions. So that's what.
So basically, that's just giving you like a page model of the entire application there. So every object on that specific login page is automatically generated here in the form of classes and methods that can be referenced then in your test steps and in the step definitions. You can just call them easily.
Mm-hmm. Yeah, so that's basically one of the major values of TestLeft. All right, so I actually accidentally copied the model, so let me just show you the identification. It's a little more simplified in this case. All right, so that's what an individual identification would look like. So we're basically just instantiating a local driver here. And then we're locating that object based on its object identifier here and its URL as well. All right, so let's actually run this here and get a look at how that goes.
You should show the UI spy as well.
Oh yeah, let's go ahead and do that. Let's say I'm not sure what the object is in this object tree here. I could actually just pick it out right from the UI. So if I grab this pick object right here, I could just hover over that object. So maybe I want to take a look at the username text box. It will locate it right in the object tree for me. And from there, I could just copy the model of the parent object, or I could just copy the identification.
All right, so just to summarize before you run Ian, so we had a simple case that we're trying to automate in this specific scenario, and so we can identify the objects once we define the case here as a scenario and a feature file. We can reference those objects through the UI spy of the tool that embeds straight into the IDE. So that's one of the big things also here is that if a developer wants to test, it's very rarely that they want to get out of their environments. So something that embeds straight into Visual Studio or into Eclipse, something that they can use easily out of the box, and that's one of the big advantages here of integrating within their IDE. And then you use UI Spy to recognize the elements, simple ways. You don't have to guess what the methods are or keep trying. So it's something that you can easily spy on any web or desktop application. Anything
Awesome.
else?
No, I think we're good. Let's go ahead and run this test.
So one thing we're doing here is like running it straight from the IDE. So obviously we can run it off any CI pipeline. So here's the test running really quickly. So we're entering and logging in. Just entering some text here, and we're trying to verify if that order that we just placed is actually displayed here in the table.
Right. Yeah. So that happens to be the last step there. So it's just performing an assertion that, and you can actually see it at the last step in the feature file. It's just asserting that the new order is for JOH black, which is not the case. So we actually had a failure there. So let's take a look at that.
So we did that on purpose. The tool works.
Sure. So let's look at the output there. And it's going to let us know why exactly it failed. So the assert.isTrue failed, that last assertion step that I referred to. And from there, we could even open up a log file here. So under where it says attachments there, we could open that up and take a look at how this test went. So this is actually a log generated through test execute, which comes packaged with test left. So here we could just take a look and see what went on during those steps.
Yep, so simple little report here and what actions you took based on the code the automation code that you wrote. And this is easily shareable, something that you can share with various members of the team. And that essentially is how it's a really simple test in how we can sort of help the developers get into the testing phase a little more, and combine that with a neat BDD approach, and just have everyone involved and everyone on the same page in every step of the life cycle. So I want to summarize this. You have anything else, Ian?
Nope, all set.
If you can go back to the PowerPoint real quick. Just have a couple of final statements before happy to answer any questions you have. Awesome. So if we just move on to the next one. Right, so summarize, right? So couple of things that we saw here. One of the things is that automation is definitely critical to shifting left. It accelerates that process, makes it easier to sort of embrace it. But the tools that you use are totally up to you and totally up to your environment, whatever you wish to do. Everybody is involved in shifting left. Like we need the whole team to be involved. But today we saw how developers can be involved in this process in an easy way. The other thing is we don't want to forget about the UI. Normally, we spoke about this. There's sometimes we just don't think about it. So that's something that we want to stress on a little bit. And finally, so going back to the triangle, we want to make sure that we're releasing faster, we're releasing software with good quality, and with the least cost possible. So that's shift left for you. Any questions I can answer? Or Ian? Yes, sir. Thanks.
Does shift left need access to the application code in order to work?
So shift left is the term. The product that we showed you was test left. So are you talking about the product or about the?
Sorry, yes, test left.
The test left. Okay. So do you say it needs access to application code?
Does it?
No, not necessarily. No, because you're just interacting with the UI layer, so you don't essentially have to have the application code. But there is a case for doing it both together. So yes.
Essentially, the test left spy removes that.
Mhm.
You can just access that when it's right from the screen.
Great. All right, so someone online has asked us, how do you use the same example with dynamic data?
Good question. So this is something that we come across a lot, especially with web applications with dynamic data. So wildcarding, regular expressions are a couple of ways to overcome this, and usually with more dynamic apps like Angular and things like that. That's what we generally suggest is to either wildcard it or to use some expressions that you can recognize that object as static, and then you can reference it easily.
Any questions from the audience? No? Okay, we have one more online. How does test left handle web elements which do not have unique identifiers? So yes, I'd like to ask a question back there actually, but I'll try to answer this as well as I can. So again, there are a few applications. There's generally some DOM that's associated with the application that you can reference through some properties. Now, if it's not uniquely identified, again, one of the ways that we recommend, again from the previous answer, is using wildcards. I think that's something that we use. We recommend. Anything else, Ian? How do we do it with test complete? Right. So the important thing here is it uses the test complete engine. So anything that you recognize with the flagship product, you can recognize with test left also. So we've seen very few objects that are not recognizable. So. And another question: does test left support external files like the expected read from external files? Ooh, does it? Yeah, it does. Technical guy. Yeah. You want to answer more about that?
I mean, you can just like instantiate the file path right into a variable, and you can reference it that way. So that's typically how you would do it.
Great. I think that's it. So thank you, Prashant and Ian.
Awesome. Thank you.